All right, welcome to another riveting video, math video, in fact, with Mr. White. We're going to be talking about compound inequalities um, and how to write the answers in interval notation specifically. So let's get started. So here we have a number riddle, and we're going to write our answer after we solve it in interval notation. So 7 less, I'm looking right here, 7 less than the number, I'm sorry, 7 less than the numbers is less than 2, because remember the answer is a whole group of numbers. And at the same time, those same numbers, one more than twice those numbers, is 9 or more. So let's write the two inequalities because we're going to solve them that way, and then we'll write our final answer in interval notation. So for the first one here, 7 less than the numbers. Now 7 less than the numbers would be written that way. You have to put the numbers, that's your x, the numbers minus 7 is less than, the word is usually your equal sign, but here it's the inequality symbol, is less than 2. Okay, so if you solve that, you add 7 on both sides, you get x is less than 9. All right, so our answers are all less than 9. So now let's take a look at the other inequality. 1 more, right, 1 more than twice the numbers, okay, 2x, is at least, is 9 or more, is at least 9, is 9 or more. So this side is more than 9, but it can also be 9, right? If you read that carefully, it says is 9 or more. All right, so if we quickly solve that, minus 1 on both sides, 2x greater than or equal to 8, x has to be bigger than or equal to 4. So let's think about our number line over here now. Here's 9. This is a real rough graph. Here's 9, here's 4. X is bigger than that, but also needs to be smaller than 9. So we're in this in-between region. So we talked about interval notation in the last lesson. How do we write that in interval notation? Well, we put a bracket, and we start with the smallest first, bracket 4, all the way up to 9. Notice I put a comma between, and then a parenthesis because of the open circle. Now, if you've still not learned interval notation, go back and watch my other video on interval notation because it's really important that this not look like some strange other language to you, okay? Let's move on to the next one. Now, in science, the second layer of Earth's atmosphere is called the stratosphere. And this is at least 9 miles, at least. So it sounds like it could be 9 miles. Like if you're at 9 miles, you're at the stratosphere. And at the most 31 miles. So once again, if you're at 31, it sounds to me like you're just barely in the stratosphere still. So it's going to be a bracket situation because it includes it on both ends, 9 to 31. You see how easy that was? Yes, you do, right? You see how easy that is? Nod your head in vertical fashion. Okay, great. All right, moving on here. When you solve inequalities, this is a reminder from Algebra 1. When you solve inequalities, you saw me solve a couple up above. I did things on both sides. When you solve an inequality and you multiply or divide by a negative, do you remember what you do to the inequality symbol? So if it's like this, what do? You switch it around like that, okay? You switch the direction of the inequality. So for example, if you had negative 3x is greater than or equal to 9, I'm trying to figure out what x must be, and if I divide by a negative, I have giant like sirens that go off in my head, like alert symbols, like, oh my gosh, I just divided an inequality by a negative. So my little mathematical spidey sense here tells me I better darn well switch the inequality around. 9 divided by negative 3 is that. So x is less than or equal to negative 3. And that's actually the answer here. So negative infinity all the way up to negative 3 with a bracket would be in interval notation. And by the way, let's just try it. Let's just put something in. Let's go back and say, All right, let's pick a number in this region. What's a number that's between negative and infinity? Let's try negative bazillion, right? That's a number, bazillion. So if you put negative bazillion in there and then you multiply negative bazillion, I really like saying that, negative bazillion times -3, what do you get? Well, you get positive because a negative times negative is positive. 3 bazillion. Now, is that bigger than or equal to 9? Yes, it is. It is bigger than or equal to 9, so that would be a solution. So in other words, we picked a number in this region, negative bazillion, and it turned out to be a thumbs up. It's a solution, so it's a winner. So indeed, the answers are all the numbers under or equal to -3. Let's move on here. Here's another very similar example to what I just did. Now, we're going to divide by -2. I want to point out that it doesn't matter that the 8 is negative, because if you look at my previous problem, I did this on purpose because that's what I do, right? This was a positive, so, and I still switched it, okay? It was because the 3 was negative, and I divided by -3. So in this particular problem, I'm going to divide by -2. So x, I got to flip that sucker around and I get +4. So the answer is 4 and above. 4 and above would be the answer there. I wrote it both as an inequality and then interval notation, which I need you to understand. Okay, now this is an OR problem. So the OR problems, the graphs usually look where they're pointing away from, and there's this region in the middle where all the losers are, all where no solutions reside. So let's go ahead and solve this. -6 -6. -2x minus 13. Divide by -2. Divide by -2. So I get x is under 6.5. I didn't, well, I did, well, my gosh. My little spider, I was trying to go so fast that I messed up here. I should have flipped the direction of the inequality. So x is actually bigger than 6.5. So I would have gotten that wrong had I not caught it, but I usually go back and check things real quick. That's one of the advantages of showing work, so that you can quickly check things. On the other side of the problem here, I'm going to add 7 on both sides on this guy. And I got x has to be under 6. All right, so x has, let's go to our number line. Here's 6, here's 6.5. So x has to be bigger than 6.5. And then at another region of answers would be under or equal 6. All right, now that's not the answer. That's just a graph to help us visualize where the answers are. So the answers would be in interval notation. Let me write it way at the top here. It'll be, whoops, parenthesis 6. All right, let's try that again. Negative infinity all the way up to 6 with a bracket because of the closed circle, and then we union that together with another region, 6.5 to infinity and beyond, right? Yeah, you guys know that reference. Okay, great. We are doing awesome here. So this is actually an OR statement. So an OR statement ends up being a union of two regions if they're set up right. They don't always have to be. Sometimes they can actually overlap. And then you have to think about where all the answers are. So OR statements are unions of two answer sets. So we put a big fat U in the middle. So this says x is less than -1. So that would be negative infinity all the way up to -1 union. And then we start again. Oops, boy, just haven't had enough coffee this morning, you know. We're going to put a bracket. We're going to start at 3 and then go all the way up to infinity and beyond. Yeah, you probably said it with me, right? Okay, and that would be the answer. That's how you'd write that in interval notation. And I went over that on the last video. Okay, now and statements are intersections. So if x is between -3 and -1, but also could be equal, then what you do is you start with a bracket. You start with the smallest number first, and then you go all the way up to -1. And once again, I flubbed that. Good grief. All right, -3 up to -1 with a bracket at the left side and a parenthesis on the right. So again, we did this in the last video, so hopefully that feels like review. So this is an in-between question, which is an AND question. Now we want to get x by itself so that we can wrap our heads around what on earth x might look like. What are the answers? And we don't want to guess and check here. That would really hurt our brain, to be honest. So what do? Well, we get rid of the 4 and we get rid of the 2. The 6 and the 10 are just along for the arithmetic ride, I like to say. So how do we get rid of the 4? What? How do we get rid of the 4? We subtract 4. But wait, there's 3 sides here. There's 3 sides. So I'm going to minus 4 from all 3 sides. See how crazy this is? We've added a third dimension. Just wait for the 4th dimension. All right, 6 less than, sometimes I like to work backwards here because why not? Okay, now how do we get rid of the 2? How's it attached to the x? It's attached by multiplication. So we're going to divide everything by 2. Divide everything by 2. Negative 5 less than or equal to x less than 3. And there's your answer with interval, not interval notation, but as an inequality, compound inequality. So we put a bracket here, 5 up to 3. That's your shorthand. Oh, it's almost time to be done, apparently. We've got the bell going off here. So we've got the bracket, negative 5, all the way up to 3, parenthesis. So this is your primer on compound inequalities, how to solve them, how to write your answers in interval notation, and hopefully you were mildly entertained. If you like this video, go ahead and like it down below and be sure to subscribe to get the latest from Mr. White. All right, take care, guys.